Okay.
All right, I'll go ahead and start. Number two, give a 90% confidence interval of 45, or given a 90% confidence interval of 45 and 105 for mean heart rate. Which of the following is the best interpretation of this confidence interval? Confidence interval is that we are 90% confident that the true mean heart rate is between 45 and 105. Should be the second one there.
All right, so researchers at the University of Mississippi want to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. So they selected 20 females and 15 males. So they just tried to construct a confidence interval to determine if the difference of the means is significant. They created Q plots, pulled random samples to see that they are approximately normal. Are all the requirements for constructing a confidence interval satisfied? And it's yes. The distribution of the mean of each sample is normal since the data have been determined to be normal.
Yep. So I got number four. Of the four types of confidence intervals listed below, which one is appropriate for this experiment? And we've got, since they're independent, there's different means. We would use the confidence interval for the difference of means using independent samples.
Yep. All right. So this problem, the researcher is interested in estimating the savings account balance of customers in a large bank. She obtains the savings account balance of a random sample of 30 customers. But with a 95% confidence interval for the mean savings account bank balance of customers is found to be which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? And it will be obtained the bank balances of 90 bank customers rather than 30.
Yep. Yes. Let's see here. Number six. Factory makes propeller drive shafts for ships. Quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. Lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts and put your answers for the margin of error, the lower bound, and the upper bound. So this one I actually kind of got stuck on at first. I think I've got it right now. But basically, the margin of error, since we know the standard deviation would be z times the standard deviation over the square root of n, which the standard deviation over the square root of n turns out to be 1. So really all you need to do is find the z-score, which is 1.96. Is that what you got?
Yep, and I got it right. So.
Oh, perfect.
Awesome. You got it right. All right, so the lower bound, it's obviously taking the 1,000 and subtracting the margin of error, and it's 998.04.
That's what I got. And the upper bound is adding the margin of error, so 1,001.96.
Yep. All right. So, this question, to assess the accuracy of a laboratory scale, the standard weight that is known to weigh 1 gram is repeatedly weighed at a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with an unknown mean and a standard deviation of 0.01. How large should it be so that a 95% confidence interval has a margin of error of 0.0001? That would be 38,416.
Okay. How did you get that? Because I got some ridiculous number.
Did you?
Yeah, I did. So you just took. Did you take the z-score? Was that also 1.96
hmm
times 0.01
So
over 0.0001?
let's see. I can't remember. I did that one. Where's my notes on that?
Because I did this one in Excel, and I think that might have been where my problem was.
I can't find my notes on this. I made a 20 minutes on this, so I had something for the test.
Did you get this one right?
I did.
Okay.
Let me. I gotta look for my notes and find the actual how I did it because I don't remember. I don't know. You want to go back to that one at the end? I'll look through my notes as we go through.
Okay.
So the right answer is 38,416.
Oh, okay. Yeah, my problem was that I did it in Excel. It must have done a different order of operations, but I just typed it in my calculator, and that's what I got to. So,
Oh, okay. All right, you're
yep,
good.
we're good there.
Right on.
I know what I'm doing. Okay, so we're trying to find the appropriate null and alternative hypothesis for this mean area of several thousand apartments. It's 1250, and a tenant thinks that they are actually smaller. So the null hypothesis would be that they're 1250 square feet, and the alternative hypothesis would be that the mean is less than 1250. So D.
All right. In a statistical test of a hypothesis, we say we reject the null hypothesis with the level of significance if, and it's the p-value is less than the level of significance.
Yep. Let's see, number 12. There's a group of statistics students. Wants to determine if students in some apartment buildings get better grades than others. They take the GPAs from a sample size of 15 from 4 different buildings. And it wants to know if we can do an analysis of variances. The answer is yes, because it's enough to know that there's a bell shape with no outliers and that the sample variances are nearly equal. As long as we have those two items of information, it's normal. You can do it.
All right. I don't really want to read all this one, but all right. So number 13. So she rejects consequences. She rejects the null hypothesis. In a future study, has determined the new treatment does not increase the mean survival time in the population. Anyway, it is a committed a type 1 error.
Right.
She has a very low sample size.
Yeah. Well, it's because
Well,
because she rejected it even though it was actually true.
yeah.
Yeah. Which is a type 1 error. Sure. Do you remember that? Type 1 error and type 2.
I do.
Yeah. Okay. All right. Number 14. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? Those two are inversely related. So by reducing the probability of committing a type 1, you're increasing the probability of committing type 2.
Yep. All right. So the so the test hypothesis on this one, the null hypothesis is equal to 1.5, or it's greater than 1.5. So at a level 0.5 level of significance, you conclude that you should reject the reject the null hypothesis.
Mm-hmm.
That was when you figured out the
P-value.
Yeah.
Yep, p-value is less than 0.05. Let's see here. Number 16, we want to find what the correct statistical procedure is for finding or looking at the mean number of hours worked for wages per week by male students and female students. Like a random sample, 100 for each group. And since they don't have any, the males' wages don't have any bearing on the females, so it'd be an independent sample t-test.
Cool. All right. So an educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother and sister pairs when they are next to each other in sibling order. Should she use a hypothesis test base or an independent or a test based on independent or dependent sampling? And it's dependent sampling if you select a brother so as to compare his academic achievement to his sister. You must include the sister in your study.
I got C.
Hold on, let me see. Just a second. Let's see. We're 17. Really?
Yeah, because
I'm trying to think. I'm sure I got that right.
I think
Let's see. So it's not because it's not independent, because you have to choose the sister.
Well, but
it's saying you have to use brother-sister pairs when they're next to each other in sibling order.
But they're just trying to find out if academic achievement by males and females with similar academic support system is similar.
Mm-hmm.
So.
And I don't know. I'm pretty sure I put D in her.
I'm pretty. Yeah, that's throwing me off too. Because I'm pretty sure I put C, and I'm pretty sure I got it right. Huh. Well.
Whatever. We'll both see, I guess.
Yeah.
It doesn't matter. It's one.
I know that one was kind of tricky because it definitely makes it seem like, well, you have to have the samples have to be from the same family.
All right. Well, guess we'll see.
Yeah, we'll see.
Right.
18. We're trying to find which confidence interval would be appropriate for the situation of the soil samples, and we did not know the standard deviation, and so we would use the confidence interval for the mean when the standard deviation is unknown.
Yep. All right, so which of the following is the 95% confidence interval for this analysis? And put your answers. So the margin of error for the 95% confidence interval is 2.025.
Yep. Let's see here. And then the lower bound is 11.168. That one's listed in the Excel.
Yeah. And then the upper bound was 15.217.
Perfect. All right. We're looking at Hummers for New York and LA. We want to know which type of confidence interval would be appropriate for this one, looking at the difference in prices, or let's see here, the difference of means, and since they don't have any bearing on each other, it would be using a confidence interval for the difference of means using independent samples.
Mm-hmm. Yep. All right. So the lower bound was negative 423.158.
I got 423.238. Negative 423.238.
Let me look at I think I still have plugged in my Excel. Let's see here. What the heck? I wrote it down wrong. I wrote it down wrong because I looked at my Excel and it's 423.238.
Yeah, that's what I got.
Am I right? Yeah. Wow. Man. All right. Maybe I just wrote it. Maybe.
And then I got, let's see, 5417.336 for the upper bound.
Yep.
Okay.
All right. And number 25.
We're dropping rats.
All right. So the correct hypothesis for this this test for this situation is the analysis of variance.
Mm-hmm.
So,
yep. Multiple test groups.
Yep.
Mm-hmm. The test statistic for this one was 7.978.
Mm-hmm. The p-value is 0.002.
Mm-hmm. Okay, then we want to know which of the following best expresses the conclusion of this test if we're using a level of significance of 0.05. And that one is that there's sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups. Fourth one there.
Yep. Yep, that's what I got. All right. This one. 29.
So just comparing
And this
the
one
flight
was,
costs.
yeah, so you're comparing, so you need the two samples, so it's a dependent samples test.
Mm-hmm.
The last one.
Yep, and then if you type that into the dependent samples software, the test statistic is 1.685.
Mm-hmm. And then the p-value, I got this wrong in the first place, but now I have 0.096.
Yep, that's what I got.
So I got it wrong. I'm like, what did I do? And then I typed it all in again, and it was right. Or that's what I got this time. So
yeah. And then the last one, which of the following best expresses the conclusion? And if the level of significance is 0.1, and it is that there is sufficient evidence to conclude that there's a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
Yep.
Second one there.
Alrighty.
Huh. What was it, number 17 that we...
Yeah.
That's so weird. Did you already...
I haven't yet.
done it yet? I just want to look back at that because...
Here, I'll do it first. You let me know, or I'll let you know.
Well...
Let's see, 17. Yeah, it's D.
You got it right?
Yeah.
I'm almost positive that I wonder...
Well, it's like that one. Let me see if I can.
So dependent sampling. If you select a brother so that as to compare his academic to his sister, must include the sister. I wonder if it's either or. I'm gonna hit D too.
Yeah.
Just that's how much, right?
Because I don't know. I mean, yeah, just like, it makes sense. The dependent makes sense because they are dependent on each other. But then when you say it, how like you know
Right. Well,
like
because it's dependent because you'd have to use that brother and sister pair in the study,
yeah.
but the achievement wouldn't. I don't know. Anyway, it's a mystery.
So all
All
right,
right.
man. Well, good luck on the test.
Thanks. You too.
All right, we'll see you on Monday.
See ya.
All right, take it easy, man.